No, not yet.
No,
Oh,
there-
here. There it is. Okay. And okay, let's see. Okay, there is a delay.
So it's definitely a delay.
Can you full screen this?
Yeah, sure.
Okay, it's good.
It's quite a delay.
That's fine. Like that's
I think
okay.
it's a 20-second delay. Yeah, it's like a 30-second delay.
Okay. And now I
But we can't see ourselves doing that, or it's gonna get weird. You can't watch our YouTube channel.
okay, so let's just
Because you won't get feedback.
no, we just need to know that
It's working.
it's working.
Okay, good.
Okay, so but then how does it switch between the scenes? It has to switch between the scenes.
Like when-
Oh, okay. Oh, quite the delay. All right, we're good. Like I mean, we start with this, then we go with this. Now zoom. Okay. What was our Zoom thing?
Oh, it was on. Should we be in your schedule? Do you need it? I mean, I have the Zoom on here. You want it there, right?
Yeah, I have to sign in. Okay. Join.
Yeah.
So I
it
have
should be in
to
your
calendar. Yeah, it has to be in the calendar. Not this one. Open. And you need to make me a co-host. Like, all right. So, okay, join. Okay, so video settings.
Well, it's good that the other person has to get in, and we know other people can get in.
Yeah.
It's a
How
good
is
practice.
how is MacBook Pro camera? Oh, okay, so I need. Oh, like I mean, why is it not detecting OBS's thing? Okay, Zoom. New meeting? No. Join. Oh, there you go. Picked it up this time. OBS virtual camera. Okay, can you make me a co-host?
You are cool.
Did he? Oh, am I? Okay, so maybe turn your video off.
So,
Okay. Okay.
what's on is your YouTube channel. Your YouTube is still on.
Okay. I think it's all good now. So we just can you just go back to our YouTube?
Sure.
Okay, it's there with the delay and everything. Let's go back to OBS. Oh, this has become too small. All right. Okay. So I will just. Let's just say welcome. Welcome. Okay. This will become an image, which is. Let's go. Do I have that thumbnail? Where was that thumbnail? Canva. Huh? Download. It's called the red and the white something.
Red and white, what?
It's called red and white. Like, I don't know, like the background was called red and white, so it's
And
just.
me smiling.
Yeah. Okay. Okay. No, not
You
Zoom.
still
Not
you look
Zoom.
bigger than me in that picture still.
You can't get over it, man. You can never get over it.
We still got the volume on. They're picking up everything.
You're just being silly. That's why.
I know. It never hurts to remind people that it's a live mic.
Oh yeah, like I mean,
That's
all the careers ruined over a hot mic.
Oh yeah, I was listening to like some Jimmy Carr, which is a kind of a UK shock comic on Netflix.
Uh-huh.
And he has this section called Career Enders. And I was like, yeah.
Can you
Definitely a career ender.
Okay, so the sound is coming out of our.
I can mute this, but it's definitely sound.
No, it's no. I want to see if the sound is coming from the YouTube or from the Zoom.
Oh, okay. Well, it would.
Can
That's a good
we...
question. So I should be able to mute one. Have a mute all.
Oh yeah.
Yes.
Yeah.
So it's coming from YouTube.
Okay. Okay. Concurrent viewers 6. So we already have viewers.
So if I go here.
Yeah. So.
And I mute that. See?
So it's not. It doesn't have any sound now.
This one is the one where sound is coming from. And if I mute it.
Okay.
It's just from.
All right. My last step is just let's see if we can change our microphone so it sits on the desk.
Yeah, they're commenting that our mics aren't quite working. It's not echoing like it was. Seems fine. I think it's because of the cycling with the YouTube, right?
Yeah. Okay. So we will.
So we have to mute one.
Yeah. We have to mute one. We have to mute the Zoom.
The Zoom.
Or maybe the settings on the Zoom should be different.
Yeah.
Okay, let me turn this one on.
We could tell people that maybe they should go to the YouTube one if they're on the Zoom to get sound,
Yeah,
right?
Okay. Yeah.
I would say that's a good idea.
Okay. Alright, so this one, and then here again, the microphone. Okay.
Right. I think we're good.
Yeah, so you should push this,
Back.
to the end there, so this looks nicer. Okay, this is our YouTube, right?
Yeah, this one's for YouTube.
Okay, so that it does have a sound. Okay, let's it's quite the reverb on it.
Okay, how do you get to Legacy?
Yeah, let's just focus on the
Yeah, I'll do it.
mic. All right, mic. It's dashboard. Okay, so the can you turn it up a bit? Oh, here. Okay, so let's do.
Oh, yeah, but Gus can turn up here if you want.
No, I want to just see if I get the reverb. Oh, I know.
It's because Zoom, this is gone now, right?
Okay.
It's not echoing like it was. Because it was coming in both in terms of Zoom and, so we have to mute one, right?
Okay, so mute this maybe, and then I will like inside. Where's my Zoom meeting? Like,
Yeah, so this one, if we have both of them side by side, this is the only one that's allowed volume. No volume on here.
Yeah.
Right?
Okay, yeah, we just need to okay, we keep treating this as a hot mic and then keep talking so people give us feedback on how our sound is.
Okay, it's echoing now again. Okay, this should fix it.
Oh, it says, okay, this.
Luke, you're giving us some good comments here. Is it echoing still? We had two laptops and we just had to mute one entirely, and that should have done it. Just want to confirm that.
I want to see like how many people are joining through Zoom.
Okay. Yes, it's echoing.
It's echoing. Okay.
Okay, that shouldn't have happened if we put all this off.
Yeah, I'm just thinking what might have caused it.
Okay, you have YouTube and Zoom. Have you muted your Zoom on your end?
Yeah. So let's try something. Let me just leave the Zoom.
Okay.
Okay. And let's see what happens now.
Yeah, but how would you get my stuff onto yours if you do that?
We should use just one laptop.
Yeah, we'll just use one laptop and just use
That's
this
fine,
as a, to start the Zoom. I can make you the host, and then I could,
Yeah.
in case this needs to be shut down entirely, I just make you the host. Oh, because you shut down, you gotta open it up.
Okay, so can you go back to the YouTube to see if two
mics are opening.
Two mics are open.
Is this one going with the laptop? Is it?
Yeah.
So
It's just one. Okay, let me change. Oh, okay. I got it. Let's change the mic. It might be a microphone issue. Let's switch the microphone. All right. Then, oh, no, a better way. Let's just do it. Let's both same brand.
Got it?
Yeah.
So that definitely has to go in, doesn't it? Oh, I get it, how it works. Yeah, you don't have to have that.
No, it's an option.
Yeah.
Okay. No. Let's just do one last turn. Okay. Let's see. We should have sound now.
Let me turn on.
Let's check the echo thing. How are we doing with the echo?
Well, the best is other people. Okay, now it's okay.
Okay. Thank you.
What was it anyway?
It's the other mic.
The other mic, yeah.
Sometimes it's just their settings just gets mixed up. Okay, let me just do a few last checks before we run this.
Well, you've learned so much.
More than I wanted to learn.
I'm impressed with how much you've learned.
And then I will need my...
Ah, there it works.
Oh, here it works. Okay.
You might want to keep that page up,
Yeah.
just so
Okay.
you have it ready.
Huh.
You know, if it's an intermittent issue, keep it back up.
Sure. Okay.
You know,
So here.
you see?
Okay. So here, what seems to be the issue here? It's a connection to Cloudflare.
Sometimes an overly aggressive university Cloudflare system can block these sort of things. So it would work at home where you're programming it, but might not always work through a IP.
But no, it's like it's working on this side, not on the.
That's right. It wouldn't have worked on the other one. It was an IP issue.
Yeah, that's a tough one. Okay, so this is our PDF and this is our catalog. Okay, it's working here.
Yeah.
Perfecto. So our code book coming up nicely. And our taxonomy, let's see if it has my data in it.
Again, for little pieces like this, you'd want to have it preloaded.
Sure, yeah. will have to log out,
Oh, it says not enough tokens?
log in. It's just an authentication issue, which is fine. I mean, okay, taxonomy. That's the, okay.
Invalid token? Is that its concern?
Yeah, that's like, I mean, yeah, that's something to look at, but let's go here to our taxonomy.
Okay,
Here.
4 minutes.
It's up. Okay, that's fine. Let's go to, so I'll just go to my LinkedIn just to post. Okay, from HubMeta, and here let's just do repost. Please join us live here, and the link to our YouTube live.
Roya. Maybe I should tell Roya to join us soon.
Join in the YouTube. Yeah, if anyone joined in Zoom, maybe we can just ask them to join on YouTube.
Yeah.
That's just easier. Oh, and then on my personal, I will also just did it come from? Yeah, it's on my own YouTube. All right. I will just close this off. Let's close off all the distractions and let's get us going. What time?
Yeah.
10:58.
Here, we can do a quick little audio to Roya. I'll turn it on. Let me put my volume on too.
And let's see how we are doing.
Hi Roya. Just the way it's working, it would be best if you clicked on the YouTube link instead, and that way you could follow the videos. It's just we're getting some chatter between the two, trying to use two platforms, so it wasn't working. So we're going to go with the YouTube one.
Okay, so we will start a little bit of backstory, and then it's off now for a second. Then we can briefly show the old and the new.
Yeah.
Let me open up the old dashboard.hubmeta. All right, let's go and start. All right. I'll start recording too. All right, it's 11 a.m. Mountain Time.
Good morning.
Good morning, good evening,
And good day.
and good day.
That's right, depending upon your time zone.
Yeah, where you're joining from. If we can get a confirmation that you can hear us well, we will then keep our focus on the program. Let's see.
Room echo. We actually put up these tiles to either side of us, our sound absorbers as well. So.
Yeah, but yeah, today it seems to be like some other issue, which, but whatever it is, like it might be in the live, but we are also recording this, so we will share either the recorded or the live one.
Oh, they're saying it's good now. Okay.
Perfect. Thank you all very much for joining us. My name is hadi.fariborzi, and
I'm Piers Steele.
yeah, and we are, as some of you know, or many of you know, we are the co-founders of HubMeta, a platform that started to support our own research.
How long have we been doing this together?
Yeah, so again, I shared a little bit of that story on my LinkedIn. It was really 8 years ago. Like, I mean, of course,
But you also took my class.
I took your class.
So it's been over 10 years.
2014. So, and the paper
Yeah.
that I started in your class just got accepted. Good journal, though.
Well, yeah, but it's a good segue, because meta-analysis, to do a good one and a comprehensive one, is become pretty much too hard. The topics are too big and they keep growing, but our tools stay pretty much the same. I mean, I can't tell you how many people are still doing meta-analysis using Excel of all things. Now, I can't complain too much, but that's the way I was doing it 20 years ago, right?
Yeah. So it started from for the course that I had with Piers, I had like 50 papers included, which still we could do with Excel. It's not that difficult. Then a little bit more forward, when I wanted to submit to a conference, I brought it up to like 80. More painful, but almost it became too difficult to do any analysis because I had too many variables. And then comes the day of my dissertation, I had to bring it up to 110, I guess, like 2018. So,
and as you also expand not only the number of papers, but a lot of places now want to have the full correlation matrix. Yeah. So instead of grabbing one correlate from a paper, which was, basically how meta-analysis started, this with that, what's the summary? Now we're doing the entire correlation matrix. So not only is it 10 times the number of studies, it's 10 times the effects or more within the studies. So we're seeing several orders of magnitude increase.
So what I did was, like with 120, it became almost unmanageable. So I started a small version to organize everything. I hired a programmer to help me create an organizer so that I don't have to rely on Excel. And it worked very well. I did get my PhD, so I was fine. But then when we submitted and, the first round rejections and all, it kept, like my data kept becoming bigger and bigger, 160. All the while, Piers was doing the sizes of like 500 and 1,000 papers in it. So together we decided, why don't we create something that can manage these large scales?
Exploratory. Let's just see what we can do.
Yeah.
Right? Because I had tried dealing with software developers.
Yeah.
And I have to say, from a scale of 1 to 10, in terms of managing software developers, I started as 1 and I'm wasting way too much money because I got up to a 3. You need to be a 6 or 7 at least.
Yeah.
He was a 6 or 7.
So yeah, I had an experience with managing software developers. So we put our minds and monies together. So we created the first version basically for our own research. But then, and again, like I mean, the funny story is that it was not a completely planned thing. I was just standing in the hallway holding Hunter and Schmidt's meta-analysis book. He walked past and said, "What you reading? Do you have any questions?" I said, "Hey, why don't I show you this little thing that I built?" And he immediately said, "Okay, you want to do this, I want to do this, let's do it together," right? And so we started HubMeta. He wanted to name it something else. He still is insisting on it, but
I think it's funny.
Yeah, he wanted to call it 2Meta.
Yeah.
which I never got along with. So we picked HubMeta, so here we are. So we created that, expanded it, version by version a little bit. And then, funnily enough, we kept finding that it's not just us who is using it. And then it kept growing and growing. Then we hired RAs, so I recorded a bunch of YouTube videos for them and to teach in our classes. And then suddenly we saw that, people are seeing those YouTube videos. And then, one day we checked how many users we have, and it was about, 6,500, 6,000 something.
And I think this really makes a difference because we're users. So it's a ground where we're dealing with other people users, and we get the feedback direct. So we're building it from the ground up. Mm-hmm. So we know where all the little pinch points are because we experienced them. And our logic was if we could take 5 seconds off a paper when you're dealing with it, and that's something worth doing because if you're dealing with thousands of papers, 5 seconds per paper adds up.
So the versions of HubMeta that we created, let's go to the screen and see what we actually had. So here is an example. Pierce, you take it away.
Yeah, so we have a lot of different projects here.
No, it's here. It's this one.
Oh, it's that one. Okay, we're doing it that one. Okay, great. So we have a lot of different projects here. Some of them overlap, some of them that we don't. Like this one with organizational justice. So even with this platform, HubMeta, which has octable character recognition, a nice flow through, we try to make it one stop for everything. This one, as you can see, had 34 different people on it. So it was our kind of attempt to do crowd coding, and we did it, more or less. It was still really difficult. As you can see, this was 3 years ago. We submitted it this year. But it was, in order to kind of get to this size, everything of organizational justice. And I think ultimately it was over 500,000 effect sizes for that was actually coded. It took a lot of hands. And I don't think this is simply a practical kind of way. Even though crowd coding technically did work, you really would need a postdoc several years. It would require a lot of infrastructure.
You want to show the numbers?
Yeah, sure.
How many? Okay, so while it's loading, I will explain some of the reasons behind deciding to do the new version. So as you can see, this is taking a while to load.
Yeah.
And it's partly because the way we built it back in 6-7 years ago, or more. It was perfect. It was awesome. It worked very well for the sizes of like 100 projects and let's say 50 users on the platform. But it couldn't catch up with the 6,000 plus users and the crazy sizes of projects like this one, for example. Like walk us through the numbers here.
Well, it kind of starts off with a lot, right? Because you might see, for example, when we import articles, let me see, click on that. Yeah. No, just import. Yeah, there it is. Yeah. So even these number of articles that we're coming in, at the end, we have in total, I think we ended up with about 10,000. Even that number here, let's go to the title screening, we'll see it right there. Mac versus PC.
Yeah.
So
I don't want to say old versus new, but
yeah. So we end up with almost 10,000 papers after deduplication. Deduplication took a long time.
Yeah.
The deduplication algorithm that we see kind of around is mostly based around 1 or 2,000, not for 50,000.
Yeah.
And the number of our titles is now for this one to start screening is 10,000. All these things are difficult, or we've kind of grown beyond kind of the traditional architecture.
Like even like we may start writing a paper on that, like about how the Prisma algorithm, the Prisma guidelines, start from, all the steps of toddler screening, full text screening and whatnot. It was built for the days when we were dealing with 100 papers, 200, 300. The final sample of papers included in this one, like you can see our pipeline, it starts with 10,000, here 4,000 in full text screening.
We'll go to details.
Okay.
Here it is.
So here it is. So we go to 4,000. This is our Prisma. So top search is 19,000. Remove the duplicates. We have 9,000 something. Then 4,000 in full text screening. And in the end, 2,400, 2,500 papers included. So that means it's a huge sample size. And we kind of felt like, what is happening? Like every topic we pick and we do a proper search, we end up with a size, a crazy size really, like this. So
and that's not the biggest one either. You got one.
I have 2,700.
Yeah, you had to be.
I bet
you had to be me.
I had to, yeah. Sorry. Again, not old versus new now.
That's right.
All right. So anyway, so the point here is, it just became unmanageable. Simply, like look how long it takes for us to just go from page to page, open up a paper and all of that. It's just because it was built with the technologies and everything that was just simply not built for this. And then the bottom line is that I don't want to show a lot here, but we had to pay for a whole lot of servers which were not being used efficiently. It was a whole lot of data happening.
And they kind of call this type of development a kludge. In sense, it evolves more than was planned.
Mm-hmm.
So we, as people came up and gave kind of points, we try to incorporate them, sometimes one at a time, right?
Yeah, we got a lot of feedback from some of you who are seeing this video live or later. We got a lot of feedback about like things such as, oh, it would be cool to add this feature. It would be cool to add that feature. And then, many of them made sense and we slowly but surely we included them in the platform. So
should we segue to the actual platform?
Yes.
I think that's plenty of introduction.
Yeah. So I want to check that our YouTube is still going and nothing bad is happening. All right, good. So with all that, without further ado, let's launch HubMeta Ignite. Let's open the new HubMeta. This is the platform. As you have seen, you can sign up easily here. Google login usually works better, although the other one also, I tested it this morning, should be fine. So you come here to the platform, and when the first time you come here, it's obviously no projects. So you start with creating your first project. You just give it a name and hit create, and that's it. Then we go inside each project.
Oh, does that image get automatically created?
No, but that's a good idea.
Yeah, we can
why
do.
not?
We can do these things if you like.
We can just ask added little description, and then that's we can do. So here's your dashboard. We're still, thinking about what numbers would be best to show here, but so far I think this is fine. It's showing how many articles you have pulled, how many of them at what stage you have. And the concept behind this design is what we call the 4P. The 4P, which is like instead of all these different steps and all these little sub steps and the mix of different things, which was the result of Prisma being such detailed and multi-step kind of thing. We try to make it simpler like this, where you have 4 main steps. Pull, where you pull articles from all different sources into the platform. You have pick, where obviously you pick the ones that are actually relevant to your project. Prep is where you extract and code and grab information from the papers and articles that you have included. And finally push, where you just do some analysis, put things together, and just get it out of the system, right? So let's go through them one by one.
Each one of these has substantial innovations and capabilities which the other platforms have yet to adopt.
Yeah.
Right.
We have also, it's not just our own platform, we have tested many other platforms and stuff. So we hope we have integrated the best of the best. And of course, we thank you who are watching this, because hopefully you are going to join us to be a beta tester or later on just a user of HubMeta. And we are quite open to any feedback, any new feature or anything that you feel is missing or is not working the way it should be working. We are a very small team of developers, which is how many working on this? It's a team of 1. So whatever new feature, whatever new things that you want, we can actually try to incorporate and try to see if there is an issue, if there is anything. We have also a team to help us figure it out and work.
So they're asking, do we have a paper about the 4P method? Not yet.
Not yet. It's pretty new, so not yet a paper, but we will definitely draft one very soon. So it starts from import. So actually, I like to start from the search. So here in search, this is like also from the many workshops that we have taught on systematic reviews. Here you describe your research, like impact of social media on mental health. And this is just using AI to help you generate the keywords you want. You can go back and edit all of this and then change it. But basically it gives you 2 blocks of keywords. So one is about social media use, the other one is about mental health. So if once you're happy with this set of keywords, you continue to database selection. And this is just a quick and easy way to get the search terms for those, the search syntax for those different platforms. Like Scopus, this is how you would search. Web of Science, this is your code. ABI Inform this is your code. In the future, we are thinking about integrating it directly with some of them to actually pull information from them. But the biggest ones are not, we haven't been quite successful in convincing them that, they should be more open
Yeah, this is
to provide their API.
essentially what we're doing. We're doing an aftermarket fix. So ideally, we wouldn't have to go through all these steps. If the academic databases were properly contextualized and formatted and everything, but they're not, and they haven't been for a long time, despite having that capability. So we have to assume that's going to continue. But there's a whole bunch of things we can still do. For example, even at the end of the search, we can actually use all the ones you have acquired and rejected to actually see if they can devise, let's say, a new search term like a cited reference search.
Yeah.
Which you can consider.
So you can keep going back. So it does start with import, but then later on you can see, okay, it's been 2 years, I need to update this. You pick another file, add it, remove the duplicates, and then you have, just the 10% that has been added to your data. So once we do the search and we grab our files, usually all platforms provide you with file types like RIS and bibtext and so on. So these are just libraries of articles. And in this case, so far we just have the RIS method allowed, but definitely in the next iteration we can add bibtext and the other one. But RIS is the most popular one. If you have it in another format, you can just take it to Zotero or EndNote and then export again as RIS. So you upload your files. Obviously, you pick the RIS files. Here they are uploaded, and then once you are there, the first thing you want to do is to remove duplicates, because you use the same keywords for multiple different search platforms. So there is duplicates inside those files. So the way the application works, it's inside our Streamline page. So I already have some duplicated files. Let's not work with those. You pick the ones that you want to remove duplicates from. You click on the duplicate file, and it will go through that. So again, here is like I have 28,000 here and 8,000 something in this one. In many of the algorithms for deduplication that we have tested, they just cannot handle these sizes. Like it's not even the largest. Like I have another big file that can be added, and it would be like 80,000, 90,000. You are removing duplicates from those. So it's sorry, this is what we saw this morning. So the thing is, when you have a whole lot of articles, many of the deduplication algorithms that used to work very well before, they just simply fail, because it's a whole lot of fuzzy logic, pairwise comparison, and it would be like, if you have 10,000 articles, it's still a manageable size. But with 80,000, it becomes exponentially bigger to run any of those algorithms.
Yeah, in my opinion, this should be just a commodity. Everyone should pretty much have the same duplication. I was actually part of a consortium where we kind of gave all of our deduplication. I tested it, and my understanding was at the end we were going to share all of our code. Nobody shared. So, yeah. But there was another group, dedupe.
Yeah, bib dedupe was the one that we got inspired by in creating our own algorithm. You can read exactly how we remove duplicates, what is our algorithm to remove duplicates, because you might need to report it in your final article. Again, the problem is that many of the great algorithms like bibdedupe work very well with 10,000 articles, but when you want to run them with 80,000, it just becomes so cumbersome. It just cannot handle that. So we had to create a simpler version. So here it explains how it works. So after this, you you select the file that you want, like this is the deduplicated file, and then you click on merge to project. What this does is that it actually sends the all the articles, like the 61,000 of them, into the next stage. I will not run that now, but I've tested it, it works. Um, it sends it to the next stage, which is title scan. So let's go to title scan and see what we have here. Here, the idea here is to say yay or nay, included, this paper is relevant or not relevant, just by looking at the abstracts, right, and titles. So again, when your size is like 5,000, 10,000, you would hire RAs, or you would do it yourself. We have done it, all versions. Like when our size was like 2,000 to 3,000, we would do it ourselves. But when we became 10, 20,000, we hired RAs to go through all of that. But what if when you have like 40,000 deduplicated items? Like it just becomes easily 3 months of your project, and it costs a whole lot, because then you have to assume that one thing that I always wondered was that when I was doing it myself was after you do about 100, it's almost, not optional that you lose focus. You cannot keep that sharpness after a few hundred that you have done because, it's just a repetitive task. Any human being's mind just becomes, exhausted after a couple hundred.
So we've continued by with the machine learning
Yeah.
solution, which is fair. We want to upgrade it a little bit,
Yeah.
add a stopping rule,
Yeah.
which is not hard to do. It just hasn't been done.
Yeah, so here in this page, so of course you have filters and whatnot, that's not a big thing. But the real AI asset that is added here is you give your votes, like inclusion, exclusion, on a couple of them. And then what you can do is you can click on this AI rank function. So what this does is that it reads all the thousands, converts them to a vector, and then makes a similarity comparison with the ones that you have said yes to. So imagine you have a pile of yeses, a pile of no's, and a pile of on-screen. So it basically goes through all the on-screened ones and computes the similarity to the ones that are in the yes pile, and then rank orders them based on that. So it takes a while because it's of course 40,000 articles, but essentially once it's done, you will have a re-ranked item. So how you would use this is you would keep adding a few votes, then re-ranking, and then after it is re-ranked, you just keep adding more and more. So what the idea is that the more similar ones become ranked higher. So while we were talking, it finished. So the more similar ones to the pack that you said yes to become higher. You say, then you analyze this, say yes or no to a few more of them, and then you run AI rank again, like after every like 50 or 100. So you do this enough times, all the relevant ones come up, all the junk goes down.
And eventually when you've had, let's say, 50 rejects, or you apply a stopping rule, stopping rule is not hard to apply. It just would say, how many articles are you allowed to not code to basically say, don't have to do the last half or last 2/3. And you said, well, you're missing articles. Yes and no. The no part is it allows you to have a greater aperture of articles at the start, and that more than compensates for the actual missing, let's say, 5.
Yeah.
However, depends on your topic size. If you don't have a lot of articles and you have time and you want to get every last one of them, got to catch them all, then you might want to go through. It's a personal thing, but this is information, but it's very much accepted. So because we have to balance the screening with the amount of aperture we allow, and this allows a better balance.
So this is our, this is one way, this is one first step. Another step that we just developed because of the power of large language models is what we call assist, which I will show you now, and then the other two steps, which includes full text screening. So what this one does, so again, remember this AI rank here is just similarity checks between abstracts, right? Now, what if I don't want to just use a stopping rule, or maybe I don't want to hire anyone as an RA. What if I could do like 10 RA bots that would just go through all of my articles and say yes or no, and then I would see the average.
Sounds like something AI can do. It's this language, and this is.
So here, the first step, so you go through to our assist, and then you describe your inclusion-exclusion criteria. Usually, you want to spend some good time here to make it very clear what the inclusion-exclusion criteria is. And here is like studies that look at internationalization and have.
I'll tell you a little bit of a shortcut. You grab your search criteria, which is related to inclusion exclusion. You put that in an AI and say, make this into an inclusion exclusion criteria for a meta-analysis, and then small hits.
Here it is. That's the AI.
Yeah.
You didn't see this, I guess.
Oh yeah.
Because here you put it there. You say generates criteria, and it generates the criteria.
Yeah, but I'm saying in that you could put in
your
search.
We can do so here exactly. So here in this, you can just say this is my search topic, and it generates the criteria. I have, the background prompt is elaborate to create and has examples of how to create inclusion-exclusion criteria. Here it says inclusion needs to be these items, and I can manually delete them or edit them. And here are exclusion, things that should happen in a paper or an article to be included, things that you would look at to get them out of your inclusion. And you can add another set. So here I can add another set of inclusions, because let's say you have, in an ideal world, let's say you have a team of 20 people going through all your articles. To one of them you give, okay, you look at this specific thing, like, that it has to be quantitative, or it has to include these words, or it has to have this. So that's your inclusion criteria. Then another part of your team would have another set, right? So after, you can easily generate another set. And then in the next step, you can add different bots. So here, for the first inclusion criteria has one. The second, let me just add another set so we see how this works. So this creates another set. So that's set number one, set number two of inclusion criteria. And next, here you see that in this one, and for this one, I can add more bots, right? Like, let's say 3 different bots, and these are, hopefully you find them cute names for the AI bots that you assign to go through all your articles, the language model that they use to do that, and you can add more specific instructions to this bot. Like, it's like you can imagine all these bots as RAs that you have hired, and then you say, hey, you make sure you don't make a mistake of, like, let's say if this is about methodology, you say, hey, if they just say quantitative, but you didn't see enough numbers and tables in the paper, don't, or if they didn't mention anything about the sample size, maybe, err on the side of not including.
Again, that's why we definitely recommend taking iterative steps.
Yeah.
So go back, check it over, sample it, make sure it's giving what you want, fine tune it, and then done. But overall, we're changing it from 3 months to 3 hours.
Yeah.
Right.
Because then the next step is really you just click on next, and here it says, okay, which one do you want? You want deep scan, which is our full text, or you want the title scan? And then you have assigned the butts. It says, okay, you have 4 butts, 2 criteria sets, and this many papers.
Well, title and abstract.
Title and abstract.
Yeah.
For deep scan, it's like, I didn't add a lot of papers yet, so it's 3 papers. But whatever you have in your full text screening, basically, it can go through the whole full text, like the whole PDF of that.
This is where Prisma breaks down entirely, because it's based around human limitations. So because it's human limitations, title abstract, that's something small, short, and you can deal with when you have 5,000 or 6,000 papers. However, AI doesn't have that limitation. So why don't you give it the entire paper, right? That is a better, we did actually an earlier study on this, and you show, of course, the more information you give it, the better the response. So why limit the information just to full text?
Because AI can handle that. Like, the new AIs, all of them have context windows of above 400,000 characters, which is more than enough for one paper, for one academic papers. Usually academic papers are anything between 10,000 to 50,000 characters. No, words, which is around 300,000 characters.
Okay.
So, but 400,000 tokens is a lot more than this. So,
for the as you can see, when you choose to use these things, ultimately the costs are going to be a little bit more for this. So we can't. We have been bankrolling the servers and everything else since forever. This will be a win-win. Your total cost will go way down, but depending upon how much AI you want to use, there will be a small cost, but not for beta users.
Yeah. So for beta users, we are keeping it free for now, but hopefully we will get enough good feedback from you guys, helping us make sure that everything works for you. So let's go faster. So the other aspect is, inside PIC is fetch. Here is our big challenge with downloading PDFs. Here we have a couple different things. One is find PDFs, which uses an algorithm very similar to what Zotero does to find PDFs, and it searches different libraries, and depending on the day, the publisher's website sometimes allow download, sometimes they don't. Like today is obviously a bad day for them.
Yeah, it depends upon whether your IP address and all the rest of it.
Yeah.
We are going to, as we did with the previous HubMeta, integrate it with Zotero. So if you already downloaded articles previously, we can integrate.
So here is another thing you can do is, so you export as RIS. You can just take these files that you have in this page as an RIS, then import them into your EndNote, your Zotero, or wherever else you grab full text automatically. To grab the full text and then come and paste the whole PDFs over here. That feature of batch uploading PDFs is on our next to-do list. Deep scan is just the same thing, just with full text. So you have the full text here. So one thing I wanted to show you is that you want to make sure that when you want to run the full text screening, is that after you have fetched, after you have uploaded there, one thing you can do is click on this item, which is batch markdown. So what is markdown? It's basically an OCR, optical character recognition, exactly converting your PDFs into text. So this makes it a whole lot easier for AI to grab information from it and to make a decision about inclusion or exclusion.
And we've tried this, I think, every year for like 8 years.
Yeah.
When do you think it was finally got there?
3 months ago, 4 months ago,
Right.
which they introduced something very good that could actually read PDFs, academic papers, very well. So here it opens the PDF and you can read it, make your decision based on that. You can add highlights, add notes or whatnot, just simple PDF reading stuff. But again, for Markdown, it shows all the PDFs that you have and you do not have a Markdown for. So you generate the Markdown, it grabs the PDF, does an OCR of it, converts to Markdown and saves it on our platform. Of course, it takes like a couple seconds for each PDF. But
you have thousands, you do it at night and be done.
Yeah, it's all background job that we do. So you just put it there, go grab a coffee or something.
Right.
1 hour later, everything is done. So then when you have it here, you go to, so now that you have done your deep scan, which is full text screening, you grab your PDFs, you run it through all these different steps and pick the final sample of articles that you actually want to grab information from. That becomes, you have done pull, you have done pick, now prep. So with prep, you start with a catalog. So this is the catalog of papers that you have. This shows it has a PDF file. The green one shows it has a Markdown file. You click on them, it opens the PDF, loads it from your server.
You can click on the Markdown, yeah.
And then you can click on the Markdown and see how, the text. So look at that. So let's just do this again. This is the PDF, and this is the Markdown. So you come down here, see how great the text reading of that PDF has been. And I tested this with some weird PDFs too.
It used to be so awful. I mean, a table and it'd be,
Yeah.
or remember they have overlays
Yeah.
of the original text with the it's terrible.
It even grabs the tables separately. Like, perfect reading of the tables. I just have to, grab them better. But you can actually save the table as a CSV. Like that was just the table that was read directly from the article. Anyway, so we can do, it shows the figures and whatnot, everything in that paper. So that's that really helps you in grabbing information. So grabbing information, so this is our viewer module, which shows all these things, then comes pretty quickly to our codebook. So codebook is where you define the items that you want to extract data from, right? Like we have two concepts. So each project has its own templates. At first, it's empty, but we will define more and more HubMeta level, like these global level sample templates, which we think many projects would need. Like this one, for example, is sample information, like sample size, correlation type, mean age, and whatnot.
And we did a review over 100 meta-analyses, and typically the number of coding fields that most people want is very, very limited and predictable.
Yeah. So we did that for a study, right? Like the fields that are actually extracted. So we can so we'll use that to define more HubMeta templates. So this one is like, for example, independent variables, dependent variables of this paper. So basically these are HubMeta level templates. You can just click on this one and copy this into your project. It will show up here. Whatever shows up here into your project templates is what you can extract data from. Again, you open a paper. It has a side-by-side view where you see the paper on the right and the template you want to grab data from on the left. Let's say you open sample information. This is, I had already extracted data for this one. So you can just go and read it, highlight it, add notes, just the way you do it traditionally. If you want to do it manual, go and find the sample size, put the value here, and hit save. Or you can ask the AI to grab this information for you, right? So here you can grab information for a specific field, like this one, or you can add you use AI extract all to extract information for all the fields in this template.
Now, like everything else, even when you're using trained RAs, you don't achieve 100% accuracy.
No.
So how accurate would you say this one is?
Okay, it's actually a very good question. I have added this little explainer right next to it, is that models have different strengths. I spent a lot of time playing around with these models to see which one is better to do what. And it's funny, some models do very well on extracting some things, like let's say, a small sample size type, like, okay, what is the exact number? What is the exact number of mean age of participants? Or I'm giving you two options for the ethnic group, Asian or white, like which one is this paper working on? Some models, like for example, Quant3 Coder does very well with those, right? Funnily, GPT-4o does not do very well in this. Even GPT-5, it has, I wasn't quite happy with its performance. I'm guessing it's just iterations. Whatever new AI model that comes on board, we will quickly integrate into that, because it's just
like within a week.
Perhaps even like within hours, because if I am awake, I see the news.
Well, we can do it within hours, but we might take a week to get us those out.
Yeah. But it's so what we're saying is that it's very easy to integrate new models. So whatever the accuracy level, your question was the accuracy level, whatever the accuracy level is, it is right now, August 22nd of 2025. In a month, there would be 10 different new models. One of them would perhaps do fantastically, and there's no issues at all.
They've experimented with different ones, a little bit more expensive, a little more evolved ones. It was published in June 15th this year. That's how fast it's happening. And they actually showed the extraction was better for the studies they looked at compared to the coders they had. So right now, the extraction is better than the typical trained coder.
Yes, and one thing that I have faced again and again is consistency. Like you have coders, and then, for projects of big size, like 2,000, you cannot have one coder do the whole thing. You'll have multiple, a team of them. And then your consistency goes out the window. So at least with AI is that whatever this is getting, it's consistent. So here, let me show you, let's say, for example, I pick this model, I click on AI extract all. What it does is that it sends the markdown, the text version of the paper to that, and it sets the values. It grabs the values and puts them inside my field. So right now it's getting the same information. But I can keep trying with different
And we
model.
consider doing like multiple models at the same time and seeing if there's inter-model consistency.
Yeah.
So if they're all of them are actually converging on the same number, that itself is reliability or
Yeah.
validity.
Like, for example, I don't know if people noticed or not, but this thing, like for example, population type was something when I used Quantry Coder, then Gemini, grab the same sample size, but a different thing here. So which shows that there could be inconsistency. It still needs human intervention. But think of it like this, like as the researcher, yes, it is our responsibility to check all of this. Like we have to go in and see what's the data. But a fraction of the time, friction, disappointment that managing a huge large team would cause.
Yeah, I'm thinking that we can even have post analyses that once you get the raw one, saying, okay, now when you have these, sort them into specific categories, which will make it easier for analysis. So there's a lot we can do.
Yeah, and then finally, this one is kind of like a magic wand, which is the AI extract, which is after you did a few papers and you know what model does better with what template for extraction, you come here and say, okay, I feel lucky, I want to do the whole batch. So you go get started, you click on your sample, go there, pick the model that you want. Sorry, did I say sample? I meant your template. You pick your template for extraction. So here I want that sample information. Remember, we set them here in our codebook. Then click on continue, pick the model that you want, and again continue. It shows the eligible papers, like the final sample that you selected. You can select all or some of them, and continue. It says, hey, you have selected 4 papers, a total of 7 fields in one template. Your model is Quantry Coder, so that means around 28 extractions. I'm guessing it's gonna take around, this much time for this to run. And then, a fair use policy warning.
Yeah,
because this is AI.
We're kind of nervous, beta way. It's the only thing. How much exactly are you going to extract, and how many people are going to be doing that?
Yeah.
It's kind of like we might have to revisit this, but we think we're okay.
I think we are okay. Like, unless somebody just wants to come in and just.
Yeah. By the way, we'll be able to see that person, so we'll know who you are.
Yeah.
We'll have a little conversation.
Yeah. So then we start the AI batch extraction. It starts. This is the steps. It preps the data, and then it shows. It's again. You can go back and come back. It runs as a background job here. It shows. Okay, so 1 paper out of 4, and then keeps going and going. Okay, so you see, this was how much it took to imagine opening a paper. Like, this was my daily talk with my coders. Like, how many could you do today? Usually, it took between 2 to 4 hours per paper to properly open it, read it, understand it, extract data, make sure it's all there. And here we are. Like, it's still with all of those hours, we as the researcher had to go in and double check the data. We had to make sure that, because then we are publishing it. It is our responsibility.
The buck stops with you. And so there's still going to be the duty of care and verification. But this should eliminate
months of work.
Months, like 90% of your work time.
Yeah, this is not months or, 90% of your work. We have a lot of examples because we have done it the traditional way, the not so much traditional way, like all of them. Like we have all the numbers of how long and how much money it actually took us. Just to give you an idea, in a very, very efficient, using international coders, using all the good ones, in a very efficient project that had a final sample of 600, it cost us around $30,000 to collect the whole sample and around a year of work. That 30,000 was distributed between all those RAs and everything. So it's a whole lot. So
Yeah, so as you kind of go down this path, you want to extrapolate just a few years in the future. Of course, the extraction is good now. In fact, it's great now. It will get even better. It'll get cheaper, faster, and more used, which means that it is a limited amount of time before I would say every topic is meta-analyzed.
yeah. So let's do the final steps. Like we are still adding analysis and share here. The big thing is taxonomy. We have thousands of measurements, thousands of them usually in a topic. Like this one for the paper that was just accepted, 2,000 measurements, a small one, relatively. So first things first, on this page you have different views, like this one is the explorer view. This is like shows them like a table, sort them by different things, and then a tree view which shows them like a tree. And then you can import them. Of course, I haven't sat down and entered 2,000 entries myself. You import from a CSV file, and it's pretty easy to do that. So let's just find.
You're importing from the old HubMeta.
Yeah, I'm importing from the old HubMeta. Like let's pick this one. Like here, for example, you see that from whatever CSV you have, you pick the columns and match them to what we have. So we need a name and a definition for that, a type which could be a construct, measurement, or MC, whatever you've written. And then if there is a parent to that construct, and then all of that, and then you hit start import. I don't want to use that because it will mess up my taxonomy, but with that it just takes like, I don't know, like 20 seconds to import thousands of measurements into your library.
But what if I have two scales? How do I know that they tap into the same construct?
Okay, that's the big question. The thing is, usually for whatever you are measuring, there are many different measurements, right? Like I have picked two examples, very clear, like firm age, firm size. Firm age is very simple, like how many years they have been in business, right? You think it would be like maybe 1-2 measures, two different ways of people have measured that. We will see soon how that works. Like in the final sample, we had 60 different measurements, or more than 60, for firm size.
Yeah,
for firm age, 100 of them.
And I'm updating my procrastination one. And yes, I have been putting that off. It is ironic, I know that. But there's over 260 measures of procrastination, which is insane.
Yeah, so what you want to do is to put them all in the same bucket, the same cluster, so, and then attach them to the parent construct. So you have different measurements, you group them together to a parent construct. So here is what you do. It's a 3-step thing. You go back and forth again, but a 3-step thing to assign them. First, you start with the constructs that you know. These you are the person, the researcher is the best person to define this because you know your literature the best. Like let's say here, I will just add a new one here. Let's just say international speed, and then here the definition is how many years since inception until they expand internationally. Very loosely defined, right? No worries, there is an AI here that can improve this definition for you. And then you keep creating seeds. Seeds is like, your first seed of constructs that you will want to work with. So you keep adding that, so you have different constructs. And then once you have, the main ones, the ones that you are sure that these constructs should be there, you add them here. And then, of course, the better the definitions are, the better the system works. You come here. So what you do here is you run different algorithms for similarity. So here, the first one, you start with a simple one, which is TF-IDF. It just looks at like the thousands of measurements and says, okay, so let's find all the ones that are similar in meaning to firm age, right? So you run that and it generates suggestions. It takes a few seconds, not that long. And it says, okay, so firm age at first, like these could be ones that you want to consider.
Yeah, this is a very conservative choice.
Yeah.
It'll have, basically they're using the same words, not even synonyms.
Yeah, so this is basically looking at the definitions and keywords and just similarities. This is the very basic ones, but of course the fastest one. And you can play around with this confidence interval. If I bring it down and generate suggestions, it will bring more suggestions here, like more loosely defined similarity. Now you pick a few ones using this, and then the next step would be using AI embeddings. What this is that instead of just a pure library based conversion, it actually uses an OpenAI model to extract the meaning of these words, the measurements, their definitions, and then use that similarity comparison based on that. So it's a lot more powerful. It uses the power of an embedding model, similar to large language models, uses the powers of an embedding model to convert your text into vectors and then calculate similarities based on that. So the first time you run this, I don't think this is the first time for this project. The first time you run this, it has to generate those embeddings. So it takes about 4 to 5 minutes for it to run all the embeddings. But as I said, this was just reading from cache. After you run it the first time, it will be stored in your database, so you don't have to reproduce this and wait 4 or 5 minutes again and again. So here you see that I have a whole lot of different things that my simple keyword search didn't pick up. So all of these measurements, you remember I said 60 different ones? It picked a whole lot of them, right? And then what I will do is I keep adding them, accept. So this becomes the first seed and the first measurements that have to be included.
So this is really important, because if you don't know what you're measuring in meta-analysis, it's garbage in, garbage out. You're just getting a hot mess. But so the traditional way, again, that we did this was through content validation. Mm-hmm. And we would pair up and we would go through the scales and independently we'd say yay or nay, and with the degree of certainty. And then we would keep the ones that we thought. Or you would close the aperture to make it more simpler for yourself, and saying you only use the top 5 scales, right?
Yeah. So I wanted to show you something like that international speed that I defined using AI embeddings. You see
we're over a bit.
It even picks up a few things like age at first internationalization. It's not defined as it doesn't have the word internationalization speed, but if you are in my literature, you know that yes, that's exactly what it is. Like many people define age at internationalization as the international speed. So it knows very well. So it's not keyword matching, it's meaning matching.
So this again saves I would say 3 to 4 weeks.
Yeah.
But depending upon the number of constructs.
Yeah. After that, you still have a whole lot of orphan measurements, like the measurements that are just a mess. You haven't assigned them to anything. You don't know why they are coded. Now you want to find clusters of meaning, like put them into clusters that show you what it says. And this is really the final bits that we have to show. different algorithms to find like those similar clusters. It takes about 10 to 15 seconds, sometimes more, to generate those clusters. But what's happening in the background is that it goes through those thousands of measurements, puts the ones that are more similar in meaning into meaning clusters. Like, let's go through a few of them. For example, oh, here, this one is interesting. Like, if I click on that, so by the way, there is a visualization. Like, I mean, you can see that closer ones have this similar color. If I pick this cluster, it's things such as country risk, credit risk. And then we go, how is it picking up me here? That was pretty interesting. So, all the items that are in this cluster are showed here. You can kind of feel like it seems to me something like orientation, entrepreneurial orientation, or risk taking. Risk tolerance or something like that. That's a guess, right? But this is 81 items. How do I make a good guess? I can go to generate construct and ask an LLM, pass all these 81 items to it, and say, hey, please suggest a few construct names and a definition.
Or you could go back to the beginning and seed and said, I like this idea of risk tolerance. Let's make that formal and extract those.
Yeah. So the way we work with this is that we pick one of these and this definition, and then create construct. This adds it as a construct to your project, like you save that node. And then really the good way is to come back to seeds. I think we need to refresh. You come back to the seeds, and then this will ultimately show up here. And you then pick the newly defined construct, and then run this whole suggestion things all over again with that.
Ideally, in a perfect world, we would be in a science that has a taxonomy. We don't. So every meta-analysis has to recreate a taxonomy. Again, insane. But here we are. But we're now kind of on the verge, as you can see with these tools, of being able to create a taxonomy for the field. This is not the only, this is an amazing tool. It's even, but there's even other ones you can supplement, like with other people who are using. So we'll continue expanding along these lines, but again, huge time saver.
Yeah. So finally, you want to export whatever you have done. Like this one, for example, all the papers, like all the 40,000, 50,000, you want to export the whole thing. It grabs the whole, CSV of 60,000 within seconds. Then, let's say you want the full text only, or the ones that you actually ended up including. You export the papers. And then here is the data that you actually extracted. You generate an export, and then it creates that extraction for you, and then you take it out, and here, download. You take it out, and then do your analysis with them in R or...
Yeah, we're not providing a stats engine because it's best to actually do it in the one. There's just more options, and you can create the code like that. We'll give some example code attached to this that you can just run in our...
Yeah, so basically what we are imagining for our analyze page is, a little bit of analysis there, but mostly example codes, where you can say, okay, this is how we got out of HubMeta, and then this is our analysis to generate this table, that table, this analysis, and that's it. So that's basically all the features we have so far. A few quick ones. In improvements, you have the opportunity to request something, a new feature, and then people can thumbs up something that other people have suggested, or you can report a bug here. You can always email us if you saw a bug in the platform, and we would be more than happy to fix that. We are counting on you to help us fix those bugs.
Apologize for the echo. We had thought we'd fixed it. We tested it. with everyone, and I don't know why it came back again.
Yeah, so hopefully in the recorded version, we don't have this issue. So, anything else to add? We
Well,
are
do you have
10
any
minutes over.
questions? We have the chat open. There is about a 30-second delay.
Yeah.
So with using, so take a kind of a moment for actually your question to be kind of going through. But all in all, this should be able to enable small teams, as we promised, to do extremely large-scale meta-analyses. We, again, like everything, you need to check and own the data. There is a benefit from going over the articles yourself. Always have a finger in it, no matter where you're kind of going through, you make better decisions. But using yourself or your RAs or PhD students as data entryists is not a good use of your or their time. You might benefit from going over 100 studies, probably not 10,000.
Yeah. There is a question about the cost to the platform. Of course, in beta, it is free. We are not charging in beta. But of course, ultimately, there would be charges. The way we see it is it's not going to add a cost to you. It's going to make the cost of building a meta-analysis systematic review to a fraction of what it is, time and money-wise.
That's right. Where's the invite code?
The invite code, I will send the invite code on my LinkedIn, but the invite code you want to use is beta 2025. BETA 2025. Thanks for the question.
Could this be true? Oh yeah, there is. I mean, we have papers stacked upon papers, stacked upon papers. Things that we've divided about this, we actually developed an entirely new way of doing meta-analysis that's much better than probably everything I've ever used. We've already got one to recover correlations from beta weights, which no one else has ever done. So we unified two fields. And do we have that as part of the new HubMeta?
Which one?
The convert beta?
Oh yeah, we have it. It's just it will. It's as part of the link here. Is I will add it to analysis.
Yeah, we're adding analysis, so we can.
It's implemented and works.
Implemented. The stopping rules publishable. It's though I feel kind of mixed about that because I found a PhD thesis who never published it who actually did some amazing work. So I feel it's kind of derivative, but no one's published and no one's using it, so why not? I think we're getting about 4 or 5 major meta-analyses this year, with about 10 stacked up, which we just haven't got our fingers on around.
So
sure, yeah, I would love it.
The question about journals' AI policies. You can of course declare that what it is. Like everything is very transparent inside HubMeta, like what it uses. So you can say, in the data extraction, this is what has been used, and this is how we double check to make sure accuracy.
Yeah, they'll probably want to see that. And the most important thing is that you took a sample and verified it. And that usually should be enough. Will it work for Cohen's D? They're asking.
Oh, of course. It's like I would say it worked. Like with the templates that we defined. Let me show you what templates are. By the way, if anyone needs to leave, we can officially, we just hang around here answering questions. So thank you very much for being with us. We love to hear from you. We will not put this, on the recorded video version that keeps on being on YouTube. So with the idea behind project templates was whatever your project needs, you can actually define. So here I will, let's say, just say effect size, right? I can make a definition. So here it would be Cohen's D, and then here I just need to say, okay, this is a number, and then I define a description. So this is like the effect size measured as Cohen's D, and I can give more examples. Because and then basically your so here what happens is that you can just then use this template and then fill it up with AI, and then the AI will look for Cohen's D. If it finds it, it fills it here. If not, it just usually leaves it blank or something that is not relevant, which you can in your coding you can filter out. It's just then is that okay, like all the data I extracted, I have the Cohen's D. What do I do with it? Like I have Cohen's D in that, and then maybe in your analysis code, one step for converting Cohen's D to correlations or vice versa,
right.
and then that's it.
So it's we could eventually, though it's a little, I'd like to kind of fine tune that and slow it down and make sure everything else is working. But we could add automatic statistical conversions.
Yes.
So it can convert from whatever one to whatever other one. It can flag of course it can do things like flag what type of experimental or conditions it was run under. There's just another field. So you can think of it this way. The LLM doesn't really care what field you're extracting.
Yeah.
Just state the field, describe it, it'll extract it. Done.
There are a few other things that we didn't quite have time to show, like for example, in your paper selection, like there's automatic language detection using AI, like show me all the Spanish ones.
Are we putting the automatic translation in yet?
That's what I wanted to mention. Like, I mean, we will definitely add the automatic translation into this.
Yes.
Right after this. So the thing is, the list of things that people need are usually extensive. We can get. That's why I added this thing, improvements. Like if you can request more features, and then like if we saw that enough people are thumbs up. Adding thumbs up on that, we say, okay, this is something that many people need. So
right.
Let's think about it.
The please, if you like this, and we think this is actually a revolution in meta-analysis, it's something which enables us to actually do large-scale meta-analyses again. Things that a group of like 2 or 3, which is normal for meta-analysis, should be able to handle, let's say, all of job crafting. All of, for example, we're doing one on all of gender-mental building performance, updating that area. So you can think about these bigger ones. Now, if you're going to go down that path, I do strongly recommend that you still get someone here, a professor, he or she, who has mastered the topic. It's just, it's a qualitative difference. When we did the organizational justice, we got Jason Colquitt and David Long in it, and they saw things in the data that we did not, right? He said it was easy to write too, but yeah, easy after 25 years of experience. So we're not taking away personal expertise. If you really want to get something that's going to be field defining, you still need deep level mastery.
Okay. Question is, will there be a book chapter, a book, or a new YouTube channels? Yes to new YouTube videos for sure, but I'm thinking maybe in October or something, because we need to stabilize this, and then we have a few
there was an offer to do a book, but the book is I mean, it changed every few months. It was kind of like it never stabilized enough for us to even think about
We
kind of
finally
covering.
think we have it done, but definitely a paper, a short paper for the step-by-steps of the 4P, which once finished and submitted, we can put it on one of these SSRN or
Yeah,
libraries
that's
or
right,
something,
exactly.
and then we can share with everyone.
Yeah, but I'd like to kind of also get some of our new techniques out too.
Sure. Yeah.
So it's,
Okay,
it's good.
and in what areas are your current users? Oh, they are everywhere. Like I have seen things in medical, pharmaceutical. I have seen ones a lot in social sciences, but really all around. Many
Yeah.
different ones.
So we to kind of try and capture,
If you want to show something,
for example,
Just-
just to search HubMeta in Google Scholar, right? So not all of these are HubMeta, but they're one of the ones that we actually have an article for, right?
the ones that actually cite.
All references be ported into HubMeta, so that's for cancer survivors. We can actually go through and actually take a look and maybe even go through our own title.
And
Some people mention it. Some
many
cite
people
it,
have not cited us.
and
so-
some people just thanks, and
Even not thanks.
not
but,
even thank. Yeah, well, yeah, and that's human nature, isn't it? I mean,
Yeah.
is it gonna stop you from doing something good like this because people who are, let's say, they should be a little bit more considerate than they are and appreciate when people do good things, don't. That's the human nature. It's not gonna stop you, just we'll go with it. But we appreciate the recognition, of course. A sincere thank you makes your day.
Yeah. All right. Let's wrap this up. Let's see if there's any final questions.
Questions? Okay. Can this platform be used from all industries or any specific ones? That's a good question. It should be able to be used by anybody.
Yeah.
This is kind of it's just because the flexibility of these large language models, and there's something about like zero shot, which is no prior training, that they often work better with zero shot than given examples. So it's incredibly flexible. But if you've come across an area which doesn't work well, that's an interesting challenge.
Yeah. So the way, if you look at these steps, pull and pick is not really area dependent. It's completely independent of industry because the core concept is picking the right sample from the thousands of or the tens of thousands of articles. And then prep stage is, again, like catalog viewer, the same thing, area extract, similar. It's just all about the code book, which means the data that you actually need to extract, right?
And the LMMs do not care. If you wanted to say how many indefinite articles are in there, it'll do that. It really doesn't care.
Like for example, we have, like in quantitative studies, like correlational, you have the concept of tables, right? You want the AI to go and grab and try to extract correlations. Like this is something I'm working on, but you can add tables, and you see this is like the correlation table that you usually need for correlational analysis. We built this because a lot of the projects that Pierce and I work on are correlational. But there's nothing stopping you from adding here something, let's say about qualitative, like let's say, okay, grab the theories, grab quotes of, from patients or, whatever that comes to you, whatever that you need to extract from inside the articles. It could be even not for academic purposes. It could be completely for, different things. You just need a specific thing extracted from a bunch of PDFs.
Yeah. Ultimately, we want, like here would be another useful upgrade of I don't know how many. So imagine we had a test library of all the tests and all the measures. now. There's some that actually exist. You might say site tests exist like that. Site tests and APA put a caveat saying you're not allowed to use it with AI. Why would they do that? I have my suspicions, but anyway, we have to go and reinvent this now. But once you have that, it becomes a trite thing now to actually go in to an article, look at the references, saying this reference cited this measure, and this is likely the measures there. So as we kind of go along, even all these small pinch points you're experiencing, eventually will get smoothed over the next year or two. I think it'll take about 2 years to get this almost seamless, and where it's just a completely kind of honed and finished process.
All right.
All right. Any last questions? I think the last one was, can this platform be utilized by researchers from all industries or only specific ones? We'll give it a couple moments, and we have gone over a little bit, but
thank you all for being here.
Thank you all. This is an exciting time. I want to hear about your successes. We've put our heart and soul into this little thing. It's here.
Yeah.
And we want it also, we're sending it out into the world now with its lunch kit and its backpack, and we hope that it is well received.
Yes, that very well put. Okay, thank you all very much for being with us today. We will share not the final parts that we were answering questions, but the main part of the event on our LinkedIn, and you can catch up over there. Thank you, and have a great day, evening, or night.